11th March 2011. The city of Fukushima in Japan will witness a terrifying consequence of a 9-magnitude earthquake just 70 kilometers from the coast. The 40-meter tsunami waves hit the Fukushima nuclear power plant, releasing substantial amounts of radioactive material. The incident led to unprecedented protests across the world. Post-Fukushima, the safety culture of Japan's nuclear industry has come under greater scrutiny, changing people's attitudes about the country's nuclear technology. People consumed by ethics and justice started to raise a big question mark about the reliability of nuclear power plants. Environmental concerns and public safety regulations were no longer hidden beneath the ground. Uranium use yields a handful of advantages to countries that utilize them. Besides generating electricity, it can play a critical part in medical and food preservation technology. But all of the countries that generate nuclear power have relooked their safety regulations and debated on further expansion plans. While countries like Canada, Australia, and Kazakhstan are world producers of uranium, radioactive catastrophes have brought public and media attention to existing nuclear power stations. Coal-based power plants are accused of emitting greenhouse gases and impacting changes in climate. As such, many experts advocate for a pollution-free source of energy, but question the safety of such alternatives. Nuclear power stations use highly purified uranium, which is extracted from various mines across the world. Have we ever thought about possible radiation disasters in those mines? We have not. Had we contemplated the possibility, such uranium mines would have been included in the current public's discourse. During the process of mining and extraction of uranium, mountains of radioactive rocks and chemicals are left over and pose a serious threat to our ecosystem and health. Perhaps the extremely remote locations of the mines might be the reason for not getting any attention in the world's current debates. Canada is blessed with the best quality uranium in the world. Majority of its active mines are located in northern Saskatchewan, in the country's remote forest lands. Before initiating uranium extraction operations, mining companies face stiff opposition from local communities, such as the Aboriginal community that lived in those areas for generations. The issues at hand included environmental contamination that could eventually affect their local food and drinking water. Mining became possible only after settling the disputes. Although there is no active uranium mining in Newfoundland and Labrador, several high-quality uranium deposits had been discovered in the past. These are located in far-flung areas of eastern Labrador. The local Inuit communities expressed their concerns about consequential environmental hazards should mining activity begin. This is because community-based people hunt, collect berries, and engage in recreational activities in areas proposed to becoming mining stations. Ultimately, the tampering or destruction of the environment goes against spiritual values that we often disregard when looking at development from a Western perspective. Nuclear energy is used to generate around 11% of the world's electricity. Even after the Fukushima disaster, global prospects for nuclear power have not reduced as anticipated. As per the World Nuclear Association, India, China, and several other countries are going ahead with their original plans for rapid expansion of nuclear reactors. Several countries like Iran are building their first nuclear reactors. Sooner or later, nuclear power will turn around and subsequent demand for uranium will escalate. How much will the demand for uranium escalate, and how is it related to the current mining situation in Labrador? Two researchers and their team members from Memorial University of Newfoundland explored the extent and nature of the situation in the northern part of the province. Derek Wilton, a mineral deposit geologist who's been a professor at Memorial University's Earth Sciences Department since 1984, has undertaken a handful of projects in Labrador and is thus familiar with its geography. Hailing from India, Dr. Atanu Sarkar is a public health physician at Memorial University. Besides being focused in the field of environmental health, he's been involved in provincial projects for the past 5 years.
Labrador, in the Canadian context, geological context, has the second most abundant numbers of uranium occurrences outside of Saskatchewan. And uranium was first discovered in Labrador in 1954 at a small little lake just outside Makkovik called Pitch Lake by a company called Brinex. And the Kitts deposit was discovered in 1957, and then the Michelin deposit was discovered in 1967. And they did a lot of development work on these two deposits because they were the two largest ones in the region, and they almost brought them online as mines in 1979, 1980. Fukushima really put a hole in the uranium market for a while, but it has gradually been climbing up slowly from that. But it was a drastic feature that really affected the profitability of uranium mining, and it put things behind the eight ball in terms of exploration and development.
In 2011, I guess during the spring, I got a call from someone from Labrador Institute of Goose Bay of Labrador that there's one community called Makkovik. They want to see that if there any kind of environmental contamination or any health hazards due to past uranium exploration and development. But during the process, they left the company, the Brinex, which the company was responsible for the whole exploration development. They left all the rocks, and those are lying open, and that is the major concern because people feel those radioactive rocks might cause local contamination and might affect the ecosystem. So that was the beginning. Then I made my own research team because I realized there is a great deal of geological things. I'm not expert in geology, I'm a public health physician. So I talked to some geologists. There's one geology professor, Derek Wilton, who is expert in this field and who was involved in that project before. So we made a kind of good research team. Then we had one sociologist. She was also involved in our project for time being, and we also involved a number of researchers who actually did time to time all data collection. It was a good research team with the Memorial University and the community.
But in this case, we worked with the community, and there were concerns in the community about whether this old site at Kitts was having an adverse effect on the environment, and then hence on potentially on their health. So we went in there with this goal of trying to ascertain whether there were effects. Was uranium being leached from the adit? Was it flowing out of the adit? Was it flowing out of the rocks that sit out in front of it? And if it was, how far downstream was it going? And was it showing up in plants? And if it showed up in plants, then it might show up in animals, etc. So we went in there with that point of view, trying to assuage them of, determine whether there was any deleterious effects.
Like any mining activities, uranium mining can also pose threat to environment. No mining activities is purely 100% green. There will be some environmental impacts. So uranium mining as well. So uranium mining, essentially it can contaminate the local ecosystem like water, soil. When the uranium is explored from underground and goes for milling and processing, there is a chance that those leftover rocks can pose threat to environment. It can slowly transfer from the mining sites to the distant areas. The purpose of the project was very simple, to find out whether there was any contamination, scientific evidence, to make a scientific evidence of any contamination due to the past uranium exploration and development. That was the main objective. As a part of the objective, what we did, we actually did the series of various analysis, like we studied the water samples of the contaminated areas, studied the soil sample, various plant samples, fish samples, in order to see whether if there is a contamination that can transmit from one species to another species. Very similar to our sampling sites around the mining areas, we have conducted similar kind of extensive environmental sampling at the control sites, that is around the community, having the similar kind of geological features. This kind of comparative analysis gives a clear indication of whether the current contamination being done by the past mining activities. So data collection part was really very interesting and very fascinating because it needed a lot of field work, in the sense going to remote forest areas and collecting the samples, and very challenging as well because it is totally in a full wilderness. There is no internet, no cell phone. You are totally relying upon the satellite phone, and it needs a lot of hiking, 10 hours hiking some days. So it was really challenging. So what we did, we actually planned 2 sets of data collection, one in winter, another one in spring. In winter, in Makhovik, temperature was almost -35, -40 degrees Celsius. It was very cold. But we visited a place and we hired one skidoo and went to the contaminated sites, collected some water samples. All it was frozen, but we tried to drill some lakes and try to collect some water samples, some plant samples. Main research data sample collection actually we made in August, and at that time we collected all kinds of water, soil, fish, plants, all samples. That was mostly the environmental sampling. But also we did some social science survey, basically the interviewing the people, local community, and that we did with the help of our research colleague from Goose Bay. We interviewed some local people. So that was another way of collecting the samples. And we finished our sampling, then we sent our environmental samples to Memorial University lab for analysis of those metals. Mostly we analyze all metals, essentially the uranium and the lead isotopes.
The major findings were that we could detect uranium in the immediate vicinity of the kits at it and in the rock pile just below it. And we could actually detect it downstream a little tiny bit, but when we got further, it had actually disappeared and it was not showing up in the plants or the sediments that we were collecting. The other interesting thing we found, and I think that's from the scientific perspective, we found that we could use lead isotopes as a marker of how far uranium might be spreading through the environment. And we could actually pick up the signal. Essentially, we could pick up the signal of a uranium occurrence a lot further with the lead isotopes. And even then, it wasn't for very far away. So there wasn't a great significant impact. There was hardly any impact at all. And I guess from the point of view of the people we were working with, Makhovik, they were most pleased that we could tell them that no, there's really no environmental or health effects due to that kits added up there.
The level of environmental impact is very minimum, very much localized. The interesting outcome of this research is a good learning experience for all of us. It is for the learning experience for the researchers, for the community, and for the government officials, that before any mining activities, what should be the proper approach to measure the existing contamination. See the past research, past information data with regard to the environmental management, with regard to uranium mining per se. There are very few studies which gives a really good idea about what was the state of environment before mining or during the exploration. This study will give some idea, some guidelines to the future researchers that how to conduct a study in other uranium mining areas before mining activities, even during the mining activities. So this study is important for that future researchers. Another fun part was that it was a wonderful teamwork, and we enjoyed every bit of it. We enjoyed working with the local community. We enjoyed sharing our finding with the local school kids who actually showed a lot of interest in this project. And also we shared with my students here. I teach my public health to my graduate students. So I shared my research with my students. They all enjoyed this and liked this experience.
The study has given some relief to the community who can now consume their local food without any fear of contamination. But the localized affected area adjacent to the added site needs to be restricted for human entry. The community will decide the best option, either by fencing the contaminated site or by putting up cautionary notice boards. The research team has contributed to the community at large by allowing the findings of their report to be publicly available. This will allow them to compare future findings with current ones, should mining companies commence their activities provincially or globally. Until then, the researchers have shown that both community members and academics can work together towards a common goal. Together, they can build broken rocks.